All right, there's a lot of little things to go through. I'll try and repeat it as we move along because there are definitely a bunch of gotchas. This is one, copy and assignment. So in C++ semantics, A equals B is an assignment. Yes, you're copying the direct value of B into A, but you have to be very particular there because that does not mean it's copying everything from B into A. If A and B are pointers, you're only copying the pointer from B into A. You are not making another object. You are not creating another object in the heap. You're just doing what's called a shallow copy, copying the pointer over. There is something called deep copy where you actually need to go in and copy all the different parts of it. Let me show you what that means. What is this doing?
It's making a new pointer.
And doing something with it.
Copying the old pointer into it.
Old pointer. How many Pokemon objects are there?
Just the one.
Two. There are two. There are not three. There are only two. You've created something called an alias, which also points to it, but there are only two Pokemon objects. If I were to go over here and do other, get name, print it out, its name would also be heap Squirtle. And if I run Valgrind, it's not going to complain about anything because there were only two objects, and notice that there were only two destructors. On the other hand, there's something called a deep copy, which is most commonly done by passing another object to the object. Now, it is best, I'm just going to call it P, to pass a pointer to that object, because otherwise C++ will create an entirely new object, copy all the values over, pass it to the function, and then deallocate it afterwards. And for a large object, that is a terrible idea. So let's just use a pointer for now. And this is luckily not that bad. Basically the same as the other, only we pass it in. Okay. Great. Well, so that's the shallow copy, and now we'll have other equals new Pokemon. Which one should we copy from? Squirtle or heap Squirtle? I don't really care, I just want y'all to guess. Tell me.
Squirtle has less to take.
Squirtle? All right. We have to create a pointer to it because it's on the stack. All right. Now it should go ahead and tell us, ooh, expected semicolon before token. Yeah. Oh, yes, of course. There it is. So now it copied Squirtle that time. So it actually created a copy. And just to show you, we're running our Valgrind, and now we lost some memory. Why do we lose some memory? Well, go ahead. What do we need to type right here? I guess we could type it earlier. Yes. We forgot to delete it. Oop, I got it. And now we freed it up. Okay, any questions on this? This does come up. Because a lot of my labs will say do a deep copy. but the point is, almost always, when you pass an object into a constructor, you want to create a completely new object from it. All right, how are we doing? Okay, that great. All right, methods. Okay, methods are like functions, or by like functions, I mean they are functions. Define object behavior, static methods versus an instance. Oh, we're not going to do that. Method overloading. Were you all allowed to, yeah, you're allowed to define the same name inside of Java, right? Like you could have a function, same name with different parameters. Good. That's overriding, overloading, two methods but different signatures. I'm sorry, that's overloading. Overriding is when you have a different class, like the subclass defines a function, and then later you're going to define one as well, and override it. And operator overloading, we're going to get to that actually, we will talk about it and then get to it more in a bit. In C++, operators like equals, plus, multiplication, double equal can be defined for your object. You cannot do this in Java, but you can in C++. Why? Well, let's say you have a matrix class and you want to do matrix addition. Well, I mean, there you are. If C, A, and B are all matrix or matrices or instances of the matrix class, you do plus, and that will actually generate the addition for you. Okay, I'm going to stop there because this gets a little complicated. But we're going to jump over to a completely different topic. Method binding. I'm going to try my best to avoid this from ever happening with any of my assignments because it's just annoying. Let teacher be a subclass of employee. Also, suppose promote is a method defined in both the teacher class and the employee class. All right, in Java, you have employee E and then E equals new teacher. In C++, is employee star E, E equals new teacher. All right, that's fine. Slightly different syntax, same meaning. Now the question is, E.promote calls which promote function? The teacher or the employee?
The employee, because type is employee, the pointer is employee.
All right. Anyone want to say teacher? Not saying you're wrong.
We'll do whichever one you don't want it to do in the moment.
In C++, the employee's promote is called. In Java, the teacher's promote is called. Oh, great. Why is that the case? Because in Java, Java doesn't do a check on what its type is until runtime. So when you call e.promote, Java knows you're actually pointing to a teacher class or to a teacher object. In C++, it is compile time, which means that the only thing C++ knows is that E is an employee. It could try and figure out if it's a teacher using static analysis, but that would be turning, well, we already went through the halting problem, so you know that that's not possible because it's trying to do it at compile time. So the only thing it knows is that E is actually an employee, so it will only call the employee promote and not the teacher promote. I'm going to try and avoid this as much as I can because this is just another reason why OOP is annoying. All right, there is so much more. It's obnoxious. It really is. We'll pause for continuing, and we're going to go over your homeworks. We actually already went through the homeworks last time. We are going to go through one more homework today, but we are going to now jump over to the class slides and start going through those instead of my slides.